Hi, my name is Shahroz Ahmed, and in this video I'll explain you the topic of forces for IB physics. So let's start off with the forces. So first of all, we'll discuss the definition of a force. What is a force? So in simple words, we can say a force is basically a push or pull on an object. So I'll write it here. A force is a push or pull on an object. So this is what force is all about. So if we have an object over here, we can apply the force on this object. So this is the push of the force. Or if we have an object and we pull this object towards us, so then this will be considered as the pull of the force. So this will be considered as the pull by this force. Now after this definition, we have to discuss about the free body diagrams, in which we'll see multiple forces that will be exerting on a single object. So let me just erase it and we'll discuss the free body diagram. Alright, so in the free body diagram, let me just draw a figure in which an object is placed on an inclined plane. This is the object, and this plane is forming an angle theta. Now the weight of this object is acting vertically downwards. So this is the weight. I'll consider that this object is not moving. This object is in equilibrium. So the sum of all the forces that will be exerting on this object will be equal to 0. And we will first of all we'll see how many forces that are acting on this object. So the first of all, the weight. The next force is the normal force, that is perpendicular to the plane on which it has been placed. So this is the normal force. Now because the object tends to move downwards, so this force will be equal to mg sine of theta. And the force that is holding it is the force of friction. So in this direction we will have the force of friction. I'll represent it with F in subscript small f. Alright, so now in order to find out the normal force, our normal force is not equal to mg. The normal force will be equal to this force right over here. So this force will be equal to mg cos of theta. So in this example, our normal force is equal to mg cos of theta, and our force of friction is equal to mg sine of theta. So this is a quite common problem that you see in your questions. So in those questions you can help you can get the help from these forces and get your required normal force or the force of friction. Alright, so after the free body diagram, we have to discuss the conditions for equilibrium. So there are two conditions for equilibrium. The first condition is the resultant force on an object is 0. For example, if we have an object that is hanging vertically downwards, so this is the ceiling, an object has been attached by a string with the ceiling, this is the object. The weight of the object is acting vertically downwards, but the tension in the string is pulling it vertically upwards. So in this case, the tension is equal to the weight, and the resultant force on this object is 0. Hence the object will be considered in the state of equilibrium. Now let's see the second condition. Alright, so the second condition is the resultant moment on an object should be 0. Is 0. Okay, so let's suppose we have an object that has been placed on a pivot. Some mass has been placed on this side of the object, some mass has been placed on this side of the object. Now this object will be considered to be in state of equilibrium only when the movement, the clockwise movement due to this object is equal to the anti-clockwise movement due to this object. When the clockwise movement due to this object will become equal to the anti-clockwise movement, then we'll say that this object is in the state of equilibrium. So these are the two essential conditions for the equilibrium. Now after this one, we will have to discuss the Newton's law of motion. Alright, so we have three basic laws of Newton. The first law, it says that a body remains in its state of rest or uniform motion until or unless it is exerted by some external force. So I write it here. An object will stay in the state of rest or of uniform motion until it is exerted by an external force. By an external force. So this is the Newton's first law. For example, if an object is moving, in order to stop this object, we have to exert some external force. And if the object is static, so it has been placed on the ground, in order to move this object, we have to exert some external force. If we do not apply any external force in order to stop the object or in order to move the object will retain its state of motion or of rest. So this was the Newton's first law. Now let's see the Newton's second law. Alright, so Newton's second law says that the resultant force acting on an object is directly proportional to the acceleration of the object. The more the object accelerates, the more resultant force the object will have to experience. So we can say that the resultant force that is being acting on an object is directly proportional to the acceleration. For example, if there is a car that is moving on a road in the forward direction, then the force that is being applied by the car is, let's suppose, 1000 Newton, and the backward force is also 1000 Newton. So in this case, the resultant force will be 0. If the car has to accelerate, then the resultant force should have some positive value. So let's suppose the forward force is 1000 Newton and the backward force is 900 Newton. So 100 Newton will be the resultant force. So the resultant force is directly proportional to the acceleration, or acceleration is directly proportional to the resultant force. So if there is some resultant force, we will see some acceleration in the object. And the formula for the Newton's second law will become like this: F equals to ma, where m is the mass of the moving object, a is the acceleration of the object, and F is the resultant force that is being acting on the object. So this is about the Newton's second law. Now let's discuss the Newton's third law. Alright, so the Newton's third law says that the action and reaction force acting on an object has the same magnitude but opposite direction. So this is Newton's third law. The action and reaction force acting on an object have the same magnitude, but they have opposite directions. So for example, if a person is walking on the floor, he will be pushing the floor backward. That is the action force that he is exerting on the floor. And as a result of that reaction force, he will be moved forward. For example, in case of gun, let's suppose if we fire a bullet from a gun, the bullet will move in the forward direction, so that will be the action force that is being exerted onto the bullet. As a result of that, the gun will move in the backward direction, so we will feel a jerk while firing a bullet. So these are the two examples for the Newton's third law. Alright, so after the Newton's law, we will have to discuss the work, energy and power. So let's start off with the work. Let me just erase it. Alright, so for the work, we will discuss about the work done. So work done is basically, I'll write it as work done. So let's suppose there's an object that has been placed on the ground and some force has been applied onto this object, and this object has moved from this position A to this position B. So we will say that it has covered some distance. Let's suppose that distance is d. So the work done will be equal to the force times distance. Over here the condition is that the distance has to cover in the direction of the force. For example, if you are applying the force in upward direction and the object due to some other reason has covered the distance in the horizontal direction, then we will say that no work has been done due to this force. Maybe there will be some work done due to some another force, but due to this force no work has been done. Alright, so let me just write down the definition and then I'll explain you another situation. So work done is basically, it is the product of force and distance covered in the direction of force. So this is our work done. Now let's suppose we have an object and a force has been exerted onto this object at some angle. So this angle is theta. As a result of that, the object has moved a distance d in the horizontal direction. So in this case, our work done will be equal to force times distance times cos of theta. So remember, if we are applying the force at some angle onto the object, then we will find out the work done by using this formula, Ft cos of theta. Alright, so after this work done, we have to discuss another type of work, and basically energy and work done, they are the same. Now we have to discuss the kinetic energy. So let me just erase it and then we'll discuss the kinetic energy. Alright, so kinetic energy. So kinetic energy is basically, it is the energy possessed by an object due to its motion. So the energy possessed by an object due to its motion is called the kinetic energy. So I'll write it as kinetic energy equals to half mv square. So this is the formula for the kinetic energy, and the unit for the kinetic energy and work done is joule. And joule is basically equal to Newton meter, and Newton is basically equal to kilogram meters per second square. So if we write the joule in terms of base units, so it will become like this: kilogram meter square per second square. So this is our kinetic energy. Now after the kinetic energy, we have to discuss the gravitational potential energy. Alright, so for the gravitational potential energy, it is basically, it is the energy possessed by an object due to its height. Energy possessed by an object due to its height. That is called our gravitational potential energy. So we'll represent it with GPE. That would be equal to mgh. So let's suppose this is the ground and an object has moved from this position up to some height. So let's suppose this height is h, and the mass of the object is m. So in order to find out the gravitational potential energy, and let's suppose this experiment has been done on Earth, so the value of G will be equal to 9.81. So the gravitational potential energy will become equal to mgh. So energy possessed by the height of the object is called the gravitational potential energy, and its unit is same, that is joule. So after the gravitational potential energy, we have to discuss about the elastic potential energy. Alright, so the elastic potential energy, it is basically, it is the energy stored in a compressed or a stretched spring. So the energy stored in a compressed or a stretched spring is called the elastic potential energy, and we represent the elastic potential energy equals to half kx squared, where k will be considered as the spring constant and x will be considered as the extension of the spring. So for example, we have a spring and some mass has been, there's no mass over here. Now when we, and this is the original length of the spring. So when we attach a mass with the spring, the new state of the spring becomes like this. It extends a bit. So over here, the change in height from the previous position to the new position is basically the extension, and k is the spring constant that depends on the quality of the spring, the stiffness on the spring. If the spring is stiff, the value of k will be higher. If the spring is less stiff, the value of k will be lower. Alright, so the elastic potential energy will become equal to half kx squared, and the unit of elastic potential energy will be same, that will be joule. Alright, so this is it for the work and energy. Now the next thing that we have to discuss is the power. But before discussing the power, we will discuss the principle of conservation of energy, and then we'll discuss the power. So let me just write down the principle of conservation of energy. Alright, so the principle of conservation of energy says that the energy can never be produced or destroyed but it converts from one form to another. But it converts from one form to another. And the biggest source of energy on our earth is sun. Okay, so let's suppose we are driving a car. So in the car, the fuel basically burns, and due to the burning of that fuel, the chemical energy converts into the kinetic energy. So as a result of that, the car moves. When we walk, the food that we eat contains the chemical energy, and that chemical energy converts into the kinetic energy. When we produce the energy from the wind, then the kinetic energy of the wind converts into the mechanical energy, and the mechanical energy then converts itself into the electrical energy. So this principle of conservation of energy is valid on all the practical examples, on all the daily life examples, that energy can never be created nor destroyed, but it converts itself from one form to another. Okay, so after this one, we have to discuss about the power, the concept of power, and how the power is related to the energy. Alright, so power is basically, power is the rate of change of energy, the rate of change of energy is power. We can write it as like this: power is equal to energy over time. Now energy could be anything. Energy could be work done, it could be kinetic energy, potential energy, elastic potential energy, any energy. So any energy divided by time will be considered as the power, and the unit for power is watt, and we have to put the energy in joules and we have to place the time in seconds. Now after this one we have to discuss about the efficiency of a system. So efficiency efficiency is basically considered as the ratio of the output energy produced by a system to the input energy. So the percentage or I'll just say the ratio or the percentage ratio of output energy to the input energy is efficiency. So I'll say that efficiency will be equal to output energy divided by input energy times 100. So this is the efficiency. Okay, so this is the definition and the formula of efficiency. Now let me just explain you how it works. So let's suppose we have a system. That system is doing like any useful work done for us. So let's consider this box as a system. We provide this system 1000 joule of energy, and as a result of that energy, that provided energy, our system does some work done of let's suppose 600 joules. So now this 600 joules will be considered as the output energy or the useful energy, and this 1000 joule will be considered as the input energy. So our efficiency will become equal to 600 joule divided by 1000 joules times 100, so that will be equal to 60%. So this system will be considered 60% efficient. Means it will convert the energy, the 100% energy, to 60% of useful work done and waste the remaining 40% of the energy. So this is how we can understand the concept of efficiency in any system. So this is it for this topic of forces, and now we'll try some exam-related questions.
Alright, so here we have an exam-related question for this topic. So it says an object of mass 8 kg is falling vertically through the air. The drag force acting on the object is 60 Newton. What is the best estimate of the acceleration of the object? So let's suppose this is the object. Its mass is 8 kg. So its weight that is exerting downward will be equal to mg. That would be equal to 8 times 9.81. That would be equal to around 80. So let me just calculate it, the exact values. That would be equal to 78.48 or 78.5. This is the amount of force that will be exerting downwards. Now the force that is exerting upwards is the drag force, that is 60 Newton. Now the resultant force for this one will be equal to the upward force minus the backward force, or like the downward force, or the downward force minus the upward force. So the resultant force will become equal to 78.5 minus 60. So that will become equal to 18.5. So 18.5 Newton is the resultant force. Now we will use this formula that the resultant force is equal to mass times acceleration. So from here we'll get our acceleration, that will be equal to the resultant force divided by the mass. That will be equal to 18.5 divided by the mass, that is 8. So I'll divide it, 18.5 divided by 8. So I got 2.3. So 2.3 is closer to this value. So my acceleration will be equal to 2.5 meters per second square. So option B is the correct answer. Alright, so now here we have another question. It says three forces act on a block which is sliding down a slope at a constant speed. W is the weight, R is the reaction force at the surface of the block, and F is the force of friction acting on the block. Now in this situation we have to choose which option will be correct, A, B, C or D. So it says there must be an unbalanced force down the plane. Well, if there is unbalanced force down the plane, then there would be some acceleration, but over here it says the object is moving downwards at a constant speed, so the acceleration is 0. So when the acceleration is 0, the resultant force will also be equal to 0. So for me, option D will be the correct one, but let's see option B and C as well. So option B says that W is equal to R. So W is not equal to R. R is equal to this force over here. Okay, and then over here it says F is equal to W. So F is going in this direction. F is equal to the force over here. It's not equal to W. Okay, so option B is wrong, option C is wrong, option A is wrong. Option D is the correct one, because the object is sliding downwards at a constant speed, so its acceleration is 0. When acceleration is 0, so the resultant force is 0. So this is how we'll think while doing the question. Alright, so this question is about the efficiency. So this question says that an electric motor raises an object of weight 500 Newton through a vertical distance of 3 meters in 1.5 seconds. The current in the motor is this much and the potential difference is this much. What is the efficiency of the motor? So as we know that efficiency is equal to the output energy over input energy times 100, but over here we have the output power and we can find out the input power. So for this one I'll use that output power divided by the input power times 100. So this is how I'll do it. So the output power will be measured by finding out the energy in the given amount of time. So let's find out the output power. So the output power would be equal to energy over time. So energy is mgh and the time is 1.5. So it will be like this. Now mg is 500 Newton. So it will be like 500 times height is 3 and the time is 1.5. So it will be like 1500 divided by 1.5, that will become equal to 1000. So the output power is 1000 watts and the input power will be measured by the formula of power, that is VI. So the voltage is 200 and the current is 10. So it will be like 200 times 10, it will become 2000. So 2000 watt is the input power and 1000 watt is the output power. So our efficiency will become equal to 1000 over 2000 times 100. So that will become equal to 50%. So this will have 50%. So option C is the correct one. So this is how we look the question, and we'll use the relevant formula to get the answer. So this is it for this topic for the forces. Thank you so much.